addressing mode. There is a binary value, which is used for calculating the data address, in the address field of the instruction. Indirect addressing mode. The memory address specified by the address field of the instruction is used as a target address, called the absolute address. In addition, there are some other addressing methods available in modern computers. In other modes than direct addressing mode, some sort of additional operation is performed on the address field, in order to calculate the absolute address. The target address calculated in this manner is called the effective address. (1) Direct addressing mode. The absolute address, which is the target location to be accessed as final destination in main memory, is directly specified by the address field of the instruction. It is the basic addressing mode, and is used with the next index addressing mode. The address field of the index addressing mode is called constant field. In the direct addressing mode, the program needs to be loaded in the exact same location when it is to be executed. Because of this, it is used in parts of the operating system or control program where there is a need to manage the entire memory with absolute addresses. 2. Index addressing mode. In the address field of the instruction used for index addressing, there is the index field that specifies the general purpose register number as the index register and the constant number field that specifies the address. The value of the constant is added to the content of the specified index register, and as a result, the effective address, called modified index, is generated. This mode is convenient and useful for processing a series of data sequentially in the same manner. This is because the same instruction can be executed repeatedly by increasing the index register value. 3. Base addressing mode. In base addressing mode, the starting address of the program loaded in main memory is set in the base register. The address field contains the relative address, called displacement, from the starting address of the program. When the instruction is executed, the effective address is generated by adding the value of the address file to the base register. The method of calculating the effective address is similar to that of the index addressing mode. However, it is different from index addressing in point of placing the starting address in the register in lieu of placing it in the address field. In this mode, the value of the address field of the instruction is not altered, and can be loaded and executed anywhere in main memory. Because of this, it is a necessary function for computers that are processing multiple programs at the same time in multi-programming environment. There are computers with a specialized base register and there are those that specify a general-purpose register for it. This depends on the computer model. Loading the program and setting the program's head address in the base register is the role of the operating system. Most of the computers used today use an index register together with base addressing. In these cases, The base register value is added to the address field of the instruction and the value of the index register added to it becomes the effective address. Just as for the value of the address field in this mode, how far the value is relatively displaced from the standard value is called displacement. 4. Self-relative addressing mode. Relative addressing mode. In self-relative addressing, the displacement value from the instruction address register is put into the address part of the instruction. When the instruction is executed, the address field of the instruction is added to the value of the instruction address register, in order to generate the effective address. This mode is used by many microcomputers that do not have a base register or many general-purpose registers. The instruction location of a program and the relative position of data to be processed do not change. Because of this, even in self-relative addressing, it is possible to relocate the program anywhere in main memory and execute it without changing the content of the address field. 5. Indirect addressing mode. Indirect addressing, the value that is stored at the location specified by the address field of the instruction is used as the effective address. In addition, there are cases where the index register value is added in order to get the effective address if requested. In indirect addressing, you can make various changes to the data targeted for processing, by just changing the data specified in the address field, without changing the address field of the instruction. Because of this, it is often used for handing over data between two programs. Also, because you can use arbitrary addresses in main memory, there is no limit on the number of registers. This makes it very flexible. However, main memory is accessed many times, so the processing speed is rather slower compared to other modes. 6. Register addressing mode. In register addressing, the register number is put into the address field of the instruction. When the instruction is executed, the value of the number of the general-purpose register specified by the instruction becomes the effective address. Compared to other addressing modes, the number of bits in the address field is the smallest. 7. Immediate addressing mode. In immediate addressing, the address field of the instruction contains the target data or address value itself. The value of the address field is loaded into the designated register, or accumulator, without referring to the content of the address in main memory based on the value of the address field. By setting constants, using this mode, this space in main memory does not need to be reserved, so the memory capacity of the program can be conserved. Also, since the data for processing is fetched by the execution cycle, there is no need to access to main memory again. This shortens the execution time.